Today we are gonna learn about what is burst, average and worst complexity of an algorithm. Let's discuss it one by one. Number 1. Worst complexity. It's usually denoted by the big O notation. Here given that we calculate the upper limit of the execution time of an algorithm. It's necessary to know the case which causes the execution of the maximum number of operations. Let's make it more understandable. If you are searching for a particular element that is present in the last position of a list, then you have to search till the last or maybe end the position, which is the worst case analysis, and we can denote it as the O of n, which is the big O notation. There are two cases for which the worst analysis will take place. That is, the element being searched may be at the last position in the array or maybe it is not present at all. So, in the first case, the search succeeds in n comparisons, and in the next case, the search fails even after n comparison. So, looking for an example with linear search, the algorithm performs O of n operations. Let's look at an example that we are going to find a particular item 95 which is present in the last position, and here the search goes in a way that first is compares with the first element and the second element, third element, and at last followed by 78, and then find a match that is 95 which is present in the last position, and here at last find a matches that is the last position, so it n comparison actually takes place. Here is the second example for the worst case analysis. We are actually searching for a particular element that is not present in the list. Here the example is 100. Since 100 is not present in the list, the n comparison will take place and the result will be the worst case analysis. Number 2. Average case analysis. In the average case analysis, we take up all possible inputs and calculate the computation time for all inputs. Add up all the calculated values and divide the sum by the total number of entries. So we need to predict the distribution of cases. For the linear search problem, assume that all the cases are uniformly distributed. So we add all the cases and divide the sum by n plus 1. One thing to know about average case is that it might be difficult for every algorithm. So rarely we do it. If you are going to search for a particular element that is present at the first index position, then one comparison is going to take place. And if it is in the second index position, then two comparison. Actually, we are going to sum up all the comparison. That is, if we are going to find a particular element that is present at the nth position, then 1 plus 2 plus etc. up to n comparison is going to add and finding the total by dividing up by n, then give you n plus 1 by 2, which will give you the equation for the average case as 1 plus 2 plus 3 etc. up to n divided by total number of cases, which is n. Probably will give you the total complete equation as n plus 1 by 2. Number 3. Best case complexity. Here, we calculate the lower bound of the execution time of an algorithm. It's necessary to know the case which causes the execution of the minimum number of operations. In the linear search problem, the best case occurs when x is present at the first location. Here is the simplest example. We are going to search for an item 5 from the list. Since 5 is present at the first location, then we get the best analysis, that is big O of 1.
Hello friends, now we are going to learn about how linear search implementation goes with the Python. So here this is my program using linear search and that is on Python. So here it has got three variables, list1, key and n. Let's look at what it is. List1 is the list of elements and key equal to 7. Probably I need to search for that particular element. The element is 7 here, and n equal to number of elements present in the list. And here this is the line where actually the function call takes place. Here linear search function is being called by passing three values, so that is being received here. Okay, I also seek the help of for loop here that ranges from 0 to n, and if that particular element matches with the key value here, then that element's position is being returned. Otherwise it will take the next value from the ranges, and if the element is not present, it will return the value -1 here. Okay, now since I have passed the value 7 here, it should return the result as 4 along the index position as 4. Let's look at by running the idle. Yeah, look, I have got the value 4 here. So this is how it works. Now think about a situation if I change the key value to 1. So probably I will be getting the position. Okay, I need to save this. Okay, index position at 0. So this happens when, so this is the case when the best complexity. So we can call it as the best case complexity equal to O of 1 since the element is present at the first position. And the average case complexity also goes like the same ways, like it will searches for all the particular inputs, and at last we will get that equation as n plus 1 by 2, where it actually sum up all the comparison. Like if you want to search 1 here, it will search the first comparison, and if the particular search is 5 here, then value 5, that is 1 plus 0 plus 1 plus 2 plus 3, like by likewise by the total number of cases. So the comparisons, this is how it works. At last we will get the equation as n plus 1 by 2. Okay, think about the situation when so okay, we will just look for worst case complexity. So worst case complexity means one chance is that if the particular item is not present. So let's just run it and look. Our output will be element not found. So this is an example for worst case complexity where it compares all the elements present in the list. So we can call it as the worst case complexity as big O of n since n comparison is taken place.